Hello students, welcome. Today lesson 38 form 3 topic 2 we are going to do redox titration. So previously we are done with direct titration and also back titration. So what is redox titration? It's a type of titration that involves redox reaction. In redox reaction we are saying both oxidation and reduction takes place simultaneously. So titration involving redox reaction do not require indicators because the color of some reagents change when their oxidation number change. If you go back to direct titration and back titration, we were using indicators like methyl orange or phenolphthalein indicator. So the common oxidizing agent used in redox titration are solutions of potassium manganese 7, which is written KMnO4, and we are having potassium dicarbonate 6, which is written K2Cr2O7. So the initial color of potassium manganese 7 is first of all bubble. It's bubble, so it will turn to colorless to show or to know the end point. When we are dealing with potassium dicarbonate 6, initially it is orange, so to check the end point, it's going to become green. It's going to become green. So next we are going to go and see aims of redox titration. One of the aim of redox titration is Roman A, determining a known concentration. That's number Roman A. Roman B, determining a known volume. Roman C, determining percentage purity. Roman D, determining the mole ratio. Roman E, determining the amount of water of crystallization. So each of these aims will be discussed in details. So let's go to the first aim of redox titration, that's determining the unknown concentration. Example 1. We are told 18.1 centimeter cube of 0.024 mole potassium manganese 7 solution were required to completely oxidize 25 centimeter cube of an iron 2 sulfate solution in sulfuric acid. So we are asked to calculate the concentration of the iron 2 sulfate solution in moles per liter, in part B, gram per liter. We are given the ionic equation and also the RFM of hydrated iron 2 sulfate, which is 278. So if we want to start with the part A, first of all, we have to know, do we have a standard solution? Yes, potassium manganese 7, because we know the molarity and its volume. So we can look the number of moles of potassium manganese 7. So how are we going to get moles? Moles is given by molarity of potassium manganese 7 multiplied by volume used and divided by 1000. That will be the formula. So what is the molarity? The molarity of potassium manganese 7 is 0.024 multiplied by volume, which is 18.1, divided by 1000. So here we are going to get 0.0004344 moles of potassium manganese 7. Potassium manganese 7 solution. That will be the first step. We have calculated the number of moles of potassium manganese 7. So next we have to get the number of moles of iron 2 sulfate solution. So we are given here only the volume, we don't have the molarity. In other words, we're even asked the molarity of iron 2 sulfate in part A. So that means if we have gotten the number of moles of potassium manganese 7, we can use mole ratio using the ionic equation given to find out the number of moles of iron 2 sulfate solution. So we are going to see here manganese 7 ions ratio iron 2 ions. So if we have gotten the number of moles of potassium manganese 7, let's see the mole ratio between manganese ions and also iron 2 ions using the ionic equation given. So it's 1:5, as you can see. So the number of moles of potassium manganese 7 solution is 0.004344. What about the one for iron 2 ions? We cross multiply. So here we are going to get 0.004344 times 5 divided by 1. We are going to get 0.002172 moles of iron 2 sulfate solution. So thereafter, we are given the volume of iron 2 sulfate solution, as you can see here, 25 centimeter cube of an iron 2 sulfate solution. So if we have the volume, we can get the molarity. So how can we get the molarity? So molarity is given by the formula molarity. Molarity is given by moles multiplied by 1000, then divided by volume used. Volume used. That's the formula. So here the moles of iron 2 sulfate solution is 0.002172 multiplied by 1000, which is in the formula, divided by the volume used, which we have said is 25. So using the calculator, what we are going to get will be 0.08688 mole or moles per liter. That will be part A. How we are going to answer in part A. So we proceed to part B, and in part B we are told to calculate the concentration of iron 2 sulfate solution in grams per liter. So concentration in grams per liter, concentration in grams per liter is given by molarity times RFM. Molarity, which we have calculated now, times RFM, which is given in the bracket. In the bracket we are told RFM of iron 2 sulfate is 278. This will be equal to 0.08688 multiplied by 278. So what we are going to get here will be 24.2 grams per liter. That will be how we are going to answer in question number 1. So we go to question 2. We are told 25 centimeter cube of 0.06 molar ammonium iron 2 sulfate, which is a double salt, required 15 centimeter cube of acidified potassium manganese 7 for complete neutralization. So we're asked to calculate the molarity of potassium manganese 7 given the ionic question below. So here we have ammonium iron 2 sulfate. It is molarity and volume. So we can look, it is number of moles. So I can start with moles. Moles is given by molarity, which is in our case 0.06 multiplied by volume, which is 25, divided by 1000. So here we are going to get 0.0015 moles of ammonium iron 2 sulfate solution. So next we want to get the number of moles of potassium manganese 7, but we have it is volume only. So we can get, using the ionic equation, the number of moles of potassium manganese 7. So let's have manganese 7 ions ratio iron 2 ions in the ionic equation. It is 1:5. There's 1 hidden here and there's 5 here. So we have the number of moles of iron 2 ion here, 0.0015 moles. So we can get the number of moles of potassium manganese 7. So we're going to have 1 times 0.0015 divided by 5. This we are going to get 0.0003 moles of potassium manganese 7. That will be the number of moles of potassium manganese 7. So if we have gotten 0.0003 moles of potassium manganese 7, we can get the molarity of potassium manganese 7 solution by just having the formula molarity is equal to moles times 1000 divided by volume. The volume is 15. It is given in the question. So we are going to say molarity is equal to moles times 1000 divided by volume used. So the moles is 0.0003 multiplied by 1000 divided by 15, which is given in the question, 15 centimeter cube of acidified. So if we put this in the calculator, we're going to get 0.02 as our molarity. That will be how we are going to do for question number 2. So let's go to second aim of redox titration, which is determining the unknown volume. Example, we are asked to calculate the volume of 0.025 molar potassium manganese 7 required to oxidize 25 centimeter cube of a 0.15 molar iron 2 sulfate solution in sulfurous acid. Use the ionic equation given below. So here we want to start with the number of moles of iron 2 sulfate. Moles of iron 2 sulfate. So as you know, moles is given by molarity, which is 0.15 multiplied by volume, which is 25, divided by 1000. This we are going to get 0.00375 moles of iron 2 sulfate solution. Moles of iron 2 sulfate. So next we have to get the number of moles of potassium manganese 7 using the ionic equation. So we have to say manganese 7 ions ratio iron 2 ions. So it is 1:5. 1:5. So we have the number of moles of iron 2 sulfate to be 0.00375. So what about that for manganese ions? So we are going to say 1 multiplied by 0.00375 divided by 5. So here what we are going to get will be 0.00075 moles of potassium manganese 7 solution. That will be the number of moles of potassium manganese 7 solution. So if we have the number of moles, how are we going to get volume? Because remember, we have also the molarity of potassium manganese 7. So we are going to say volume used will be equal to moles times 1000 divided by molarity. That will be the formula that we are going to use. The moles we have gotten 0.00075 multiplied by 1000, which is in the formula, divided by the molarity of potassium manganese 7, which is 0.025. Here we are going to get 30 centimeter cube. That will be how we are going to get the volume of potassium manganese 7. So that's even number B, or Roman B, of redox titration. That's the end of our video today. Thank you.